Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So, in our today's lesson, we will discuss about the peculiar behavior of lithium. As we have already learned, lithium it belongs to group 1A. It is basically an alkali metals. As lithium is an alkali metals, let's have a look on it. Some properties or the peculiar behavior means it some properties are just different from the other alkali metals because it is the first element of the group 1A. So it is the main element of the group. So it just marked some deviation from the regular trends of the group. So in this lesson, we will basically study about its deviation from the properties of the other elements, or in turn we can study about its anomalous behavior. Before that, we must have a look on the lithium. As its atomic number we have it is 3. It has just 3 electrons and 3 protons. Its symbol is Li. Electronic configuration is electronic configuration of helium to the 2si, so it can be written as 1s2 and 2s1. Next, its name is simple lithium, as that is denoting just is an alkali metals, and this line is just denoting its physical state. It is present in the solid state at 20 degrees Celsius or Fahrenheit 68. This is its crystal structure, that is showing it is a body centered cubic form, so it is present in the cubic form. And the dark blue color is providing about its acidic and basic nature. So basically lithium is strongly basic in nature, and its atomic weight is approximate 6.9 to 6.99, or we can also write it as 7. So this was a simple overview about the lithium. Now let's discuss its anomalous behavior. So when we have anomalous behavior of lithium, it is just due to some reasons. Now what are these reasons? The first one reason, it is extremely small in size, as electronic configuration of lithium is 1s2 and 2s1. Its size is too much small. In the center we have the nucleus. Around the nucleus we have its two shells, and its first shell contain 2 electrons and the last shell contain 1 electron. So this is the electronic diagram for the lithium. It is very small in size as compared to the other alkali metals. Then it is having greater polarizing power of the ion, as when it just changes into the ion after the loss of 1 electron, then it just has this electron and changes into the cation +1, or we can also write it as lithium +1. In this way it is having high polarizability because the one thing, there is only a single shell, and there is no shielding effect between the electrons of the valence shell and the nucleus. So that's why it is having high charge density and very small radius. As it is having very small radius and high charge, so that's why it is having high polarizing power. Then it is least electropositive character. As we are moving down the group from lithium to sodium and from sodium to potassium, their electropositive character increases. But the lithium is least electropositive among all, and other hand it is having no d orbital or non-availability of the d orbitals. It just makes the behavior of the lithium peculiar, or we can say that anomalous from the other group elements. Then we have the reactivity of the lithium. When we talk about its reactivity, we just see that lithium is least reactive among all the other elements in the periodic table. And what is the reason behind that? Lithium is much harder, and it is also lighter than other elements. It is harder and lighter than other elements, and the lithium salts of anions, they have high charge density, and they are also less soluble in water than those of the other alkali metals. For example, we have lithium. When it reacts with the water, lithium hydroxide, we have its lithium fluoride, we have lithium phosphate, and we have also its carbonate, that is lithium carbonate. So all these are its salts of the anions. They are less soluble in water. But on the other hand, when lithium get reacts with the water, then there is a production of the a gas, which gas is known as the hydrogen gas. On the other hand, when we talk about the complexes of the lithium, so lithium forms the type of complexes that are stable complexes, and one of the stable complex that has been made by the lithium, it is the lithium mide, which is lithium NH3 whole 4, and it is having the positive charge. So this is the complex of the lithium. On the other hand, it reacts with the water very slowly, while the other all the alkali metals react violently or fast. So this is the simple properties of the lithium that are different from the other. Then we have the oxides and hydrides of the lithium. Oxides mean when lithium reacts with the oxygen, it changes into the oxide. On the other hand, when it reacts with the hydrogen, it changes into the hydride. So here we have the lithium oxide, which is Li2O, and we have the lithium hydride. So both oxides and hydrides of the lithium. Lithium hydride is more stable. So its hydrides are more stable as compared to the other alkali metals, because the lithium compounds are more covalent. That is why its halides are more stable. So the reason is because they are more covalent in nature. On the other hand, the lithium is least reactive metal of all the alkali metals. And when we burnt the lithium in air, it forms the oxide. That oxide we called as the normal oxide, whereas the others like sodium, potassium, they form peroxides, as well as they form the superoxides. So this is the simple reason for the peculiar behavior of the oxides and hydrides of the lithium. Then we have carbonates and nitrates of the lithium. When we talk about its carbonates and its nitrates, the carbonate of the lithium, we have lithium carbonate. When it dissociate, it just form the two products, that is lithium oxide and plus carbon dioxide. So the lithium has low electropositive character. Its electropositive character is low as compared to the other elements. Thus, its carbonates and nitrates are basically not so stable. Both its carbonates and nitrates are not stable. They readily converted into another products like this. And if we have the nitrate, its formula can be written as lithium nitrate, and it can be converted into the lithium oxide plus nitrogen dioxide. So this was the simple about the peculiar behavior of the lithium from the other alkali metals. I hope you guys understand, and if you have any queries you may ask me about that. And the next topic that we will discuss, it is the peculiar behavior of the beryllium. For that time, you guys have a good day and love.